A classic type of question in probability is drawing balls from urns. I don't happen to have an urn full of balls handy, but I do have a pile of paper clips. So in my pile of paper clips, I have 5 red ones and 3 blue ones. My goal is to draw 2 paper clips without replacement, and I want to find out what the possible outcomes are and the probability of each of those outcomes. It's not that there are world questions that are going to be urgently answered by drawing balls out of urns, but this type of problem does represent things like drawing cards out of a deck, say if you're playing blackjack or poker, both of which are critically important if you live here in Las Vegas. So there are applications of drawing balls out of urns. I want to use a tree diagram to represent this experiment. I'm going to draw 2 paper clips out of my pile. So I'm going to do them one at a time. The first set of branches for my tree, here's my starting point, is going to represent what might happen on the first draw. On the first draw, I could get a red one or I could get a blue one. So that's the first set of branches. I'm going to put on each branch the probability that that's going to happen. The probability I get a red one, well, there's 5 red ones out of 8 total, 5 out of 8. The probability I get a blue one is 3 out of 8. Now I'm going to make the second draw. If I got a red one the first time, on the second draw, I could get either a red one or a blue one. So here's my second draw. If I got a blue one the first time, on the second draw, I could get either a red one or a blue one. And I'm going to put probabilities again with each branch. I'm drawing without replacement. So if I got red on the first draw, that means after the first draw, there's only 7 paper clips left in my pile, and only 4 of them are red. We always make the second draw assuming that we got what we wanted on the first one. So 4 red ones left out of 7 in the pile. After the first draw, if I got red, there are still only 7 paper clips left, and 3 of them are still blue because I got a red one the first time. It didn't affect the number of blue ones. These are conditional probability ideas. If I got a blue one on the first draw, then once again, there's only 7 paper clips left in my pile. It was blue, so there's still 5 red ones in the pile. If I got a blue one, then the chance my second one is also blue, where there's only 7 paper clips left in my pile. And now only 2 of them are blue because I got a blue one on the first pick. Outcomes from this experiment, I'm going to start at the beginning and trace my way out to each end here. I could get red and another red. I could get red and then blue, blue and then red, or blue and another blue. The probability of each of these outcomes I can get by multiplying down the branches. So for 2 red ones, I have 5/8 times 4/7. I'm just going to multiply all the ones that are on the same path there. Which is 20 out of 56. And you can reduce that or use a percentage or whatever's most convenient. The probability I get 2 red ones, 20 out of 56. It's not quite half. The probability I get a red one and then a blue one, I got 5/8 times 3/7, which is 15 out of 56. Blue one and then a red one. I have 3/8 times 5/7, which is the same after we multiply. Right, what I said now. 3/8 times 5/7, which is also 15 out of 56. And the probability both of them are blue. Well, there's fewer blue ones than red ones, so this is the smallest probability. 3/8 times 2/7, which is 6 out of 56. So then you can ask variations on this theme. What's the probability that they're both the same? Or both the same color? Well, that's either both red or both blue. So I'm going to add those two together. 20 plus 6. And so on.